Hello, welcome to Home Science Lessons with Mr. Mac. Lesson 7, Domestic Uses of Electricity and Electrical Safety. So remember, turn your phone off or put it somewhere out of the way. Make sure there aren't any distractions. Get a bit of pen and paper as well, and anything else that you think you might need. Right, here we go then. So a couple of slides of retrieval on the current topic and on an old topic. A couple of examples of modelling under the camera, and then an opportunity to drill and embed the knowledge, and obviously a bit of time to practice too. On retrieval then, slide 1 is cell biology and cell transport. Pause the video, have a go, and I'll reveal the answers in a couple of seconds. Okay, there's the answers to those questions. Next slide. This is about the current topic, series and parallel circuits. So this slide focuses on series circuits. Have a go, write down your answers, go now. Here are the answers. Next slide. Parallel circuits. So the opposite of what you've just done on series circuits. Have a go, pause, write down your answers now. Answers for this slide then. And last time we did thermistors and LDRs for our lesson, and we had some practice questions, slot 5, that were attached to that video or on Show My Homework. So those are the answers for our thermistors and LDR questions. So mark your answers, please, and add any corrections. Also add any corrections that you need to, that you didn't get right from the starter retrieval practice slides. Okay, new learning then. So the first bit of new learning that we're going to do is on alternating and direct current. So I'm going to do a little bit of modeling under the camera for that. Okay, so new information. What is the voltage and frequency of voltage for UK domestic electricity supply? So get your pen, paper out, write down a few notes on this, please. It's not for watching only. This is where you have to be proactive as well. So the voltage is about 230 volts, and the frequency is 50 Hz or 50 Hertz, meaning the current changes direction 50 times a second. So that's our normal mains voltage. It's going backwards and forwards 50 times a second, and it's alternating current. So next part of it, piece of information, what does AC stand for? AC stands for alternating current. Which changes direction 50 times a second in the UK. And that's known as mains electricity. So anytime you plug anything in, you're getting that out of the plug socket at a frequency of 50 hertz and a voltage of 230 volts. So last piece of information here for this particular page. What does DC stand for? DC stands for direct current, which only flows in one direction, e.g. from a battery. So mains is going to be alternating current and a battery is going to be direct current. And we've got a couple of nice little pictures here at the bottom. So this is like the model we've been using previously. So those little red dots are free electrons that are able to move through the wire or through the substance. And they're all moving in the same direction. Alternating current, they can go this way or they can go this way. So our next piece of information about direct and alternating current, you can represent it graphically. So if you need to, pause the video, finish any notes that you're doing on this. And then we've got our next page, and then this has some information on it, again, about direct and alternating current. So we've got time on the x-axis and voltage. I'll even write that in for you on the y-axis. So direct current, we simply just get a ruler and we could draw a straight line, because in direct current it's always flowing in the same direction. But with alternating current, now here we've got positive and negative voltage. That's just to do with the direction that it's going. So if we say it's going forward or going one way, that's positive. If it's going the opposite way, that's negative. So if I was to draw what a alternating current looks like, it's this wave effect. And we can say the height of the peak or depth of the trough is going to be 230 volts, because that's our UK mains. And the time taken, not the wavelength, but the time taken, so we could measure that across the x-axis, and that would be 1/50th of a second. So that's how long it takes to change direction, or to change direction and go back again. So that's how long that amount of time is. So if you could make sure that you've got any notes written down that you need. And get ready to embed that knowledge. So a little bit of drill, 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 drill is thrill. So what do we mean by that? Well, we want to drill the information and get it to stick in our memory. So what we need to do is read over the notes that you've just made, cover them up, and then write down what you can remember. Or alternatively, get someone at home to test you on that after reading through it and ask you a few questions. So now is probably a good time to pause the video for 5 or 10 minutes, do a bit of embedding of that new knowledge. So go for it. Okay. Our next bit of new knowledge is about how a plug is wired and some of the information that we need for that. So as you can see from the diagram, we've got a neutral wire on the left, which is blue, BL for blue, the L after the B, you can use that as a memory cue to remember that it's on the left. So blue, left, brown, which is the live wire, BR, right, and then earth wire is in the middle. So that's what it looks like. So what do these wires actually do? And what is it that we need to know about them? So again, we're going to do a little bit of modeling under the camera before we drill on that information. And here we have it. So the live wire, what color is it? And what is the role of the live wire? These are all things that we want to know. So get your pen and paper ready and get ready to write down any notes that you need. And we'll get started then on that. So the live wire is a brown color, as we said before, and carries the alternating potential difference from the supply. So that basically means it takes the current, carries the potential difference into the device from the mains or wherever. It's most likely to be mains if it's going to be alternating. What else do we need to know about it? The potential difference is equal to 230 volts. And another little piece of information, the live wire should not touch the earth wire, as a very big current could flow, causing a fire. And sometimes that happens if we have loose wires or badly fitted plugs, or wires become frayed or loose over time. Sometimes that happens and causes an electrical fire. What about the neutral wire then? Well, if you remember from the diagram, it's a blue color and completes the circuit carrying away current. So if the live wire takes the current in, the neutral or blue wire takes it out back to the mains. So blue color completes the circuit carrying away current, and the potential difference is the same as potential difference of the earth, or practically 0 volts. What about the earth wire then? Very important wire in a plug. Well, first of all, it is a yellow and green color and is a safety wire to stop the appliance becoming live if a fault occurs. Because the last thing you would want is to touch a device which has a loose earth wire and then pass up 230 volts through you, causing electrocution and terrible injuries or death. So yellow and green color, and is a safety wire to stop the appliance becoming live if a fault occurs. So a little bit about how it works. The potential difference equals 0 volts and only carries a current away if there is a fault. So normally the earth wire doesn't actually do anything. It's just there as a precaution in case the live wire isn't going where it should. And it has got a low resistance and it can carry current away to the earth if there is a fault. Normally the neutral wire takes the current away. So how does this actually happen? So the earth wire has a low resistance. This allows a larger current to flow, melting the fuse. So that the fuse is attached to the live wire, and when a larger than usual current flows, that causes the fuse, which is a tiny bit of thin wire, to melt and eventually stops any more current coming into the device. So say the live wire becomes loose or there's a fault with the live wire, the earth wire takes over from the neutral wire, and because it's got a lower resistance, more current can flow, and that increased current flowing into the device will melt the fuse. So that's how the earth wire works in terms of safety. The bottom of the page here, which is going to be a diagram of a plug, but I've already put it on the PowerPoint for you on the video if you need to go back and have a look again. Terribly sorry, wrong share. That's better. So remember, with that information, drill, 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 drill is thrill. Get someone, have a good read over it once you've made your notes. Get someone to test you on it. And even better, if you can do both things, do a bit of look, cover, write, check. So read over it, write what you can remember on a blank piece of paper, and then go back and check and add any missing bits of information. So we've had a look at the new pieces of information. So now it's time, once you've spent some time actually embedding it and drilling on it, it's time to apply the knowledge and see what you can recall. So SLOP Task 6 is attached to Show My Homework if you want to access it there. Otherwise, it's on the next slide. So have a go. So fill in the two draw and fill in the two tables, or print it off, Show My Homework if you prefer, and fill in the blanks. And that it's about direct current, alternating current, and the colors of wire in a plug and what they do and what their potential difference is as well. So pause the video, spend a little bit of time doing that, please. Thank you very much. So our next lesson is going to be on power and energy transfers. Until then, remember, don't just look at this information once, look at it a couple of times, maybe even 3 times during the week. Very short, sharp intervals. Get someone to test you on it. Complete the SLOP activity that you've just seen, or any of the other SLOP activities from this week's lesson. And then look out for your recall test, likely on Friday, occasionally on a Thursday. And have a go. Put what you can remember and what you've learned, put it into action. And, you know, if there's anyone out there who's still not having a look at these videos and really doing some good science learning from them, tell your friends. Thank you very much. So thanks in advance for doing the STOP activities, for doing all that testing and retrieval practice, and for the recall tests. Thank you so much for your hard work. So it's just time for me now to say thank you and see you soon. Goodbye.